All right. Today we're going to be talking about literal equations. Literal equations are kind of different than anything you've probably seen before. However, I think it's something that we can all achieve. You'll notice here we have our main idea. A literal equation is one with multiple variables. Now there are two reasons why we care. The first reason is it is good practice for our math rules. You can't do these unless you're really good at all of those properties that we've been practicing in the last couple of days, including the last unit. The other reason we care is for formulas. In science, we have formulas to figure out specific things, and these are all literal equations. We will spend more time on this tomorrow. Now, an important thing to know is instead of getting a single tidy number, our answer is going to be a little bit more complicated than that. But so long as you trust the process and remember all of the rules that we already know will stay the same, then things are going to be okay. So let's go ahead and look at the literal equation here. We have x plus y plus z is equal to w. Do we know what those variables stand for? We don't. And it doesn't really matter. We are being asked to solve for x. So all that we really care is that we get the x by itself. So what is our goal? To get the x by itself. So in this case, let's look and see what is keeping the x from being by itself. The y and the z. Now I like to ask myself, what is connecting the y and the z to the x? In this case, I think it is addition. So how do we undo the addition connecting the y and the z? Let's start with the y first. Well, to undo the addition, the opposite is subtraction, which will give us x plus z is equal to w minus y. Remember, if you subtract one thing from one side, you also have to subtract it from the other side. And I know we don't necessarily have a single number here, and I get that it kind of looks confusing. But the intent is the same. Our goal is just to get the x all by itself. So let's go ahead and do the same process for the z. We're going to subtract z from one side, which means we have to subtract it from the other as well, giving us our answer of x is equal to w minus y minus z. We cannot simplify it any further. There's nothing else to do. We have met our goal, which was to get the x all by itself, and even though we didn't get a single answer for our answer, this is what we are looking for. So let's go ahead and try another example. We have mx plus b is equal to 3, and our goal is to get the x all by itself. Now in this case, I see two things keeping the x from being by itself. I see we have an m and a b keeping the x from being by itself. Now technically you can get rid of these in any order. However, I think it's easier to get rid of the b first and then get rid of the m. So let's go ahead and get rid of the b. In this case, we are adding the b to the x. So to undo that, we would simply subtract b from both sides, giving us mx is equal to 3 minus b. Now, once again, we don't necessarily know what 3 minus b is, but we have followed the rules of math, so this is all perfectly legal to do. From here, we need to get rid of the x. Now, since there's no other operation stated, the relationship between the m and the x is multiplication. So to undo the multiplication, we divide by m. giving us our answer of x is equal to 3 minus b over m. Once again, I know that it looks kind of messy, but that's as far as we can reduce it. There's nothing else we can do. So let's go ahead and look at our next example problem. Solve for k. Now this one's interesting because notice we have a minus sign right here. That minus sign is kind of tricky. Now, since we are subtracting the k, if we were to simply move the n to the other side, we would still have negative k. So in this particular case, I think I'm going to do something kind of strange. I'm actually going to add k to both sides, giving us k plus m plus p is equal to n. Now you'll notice the k is not negative, it is positive, which is what we want it to be. We don't want to solve for negative k, we're solving for positive k. From here, we're going to kind of do what we did in the last problem. I'm going to subtract m, and I'm going to subtract p over to the other side, giving us k is equal to m, nope, I lied. K is equal to n minus m minus p. Our last example problem. In this case, it's the exact same equation as the last one, but we're solving for a different variable. In this case, we need to solve for p. Now, what is keeping this p from being by itself? Just the m. So all we have to do is simply subtract the m over to the other side, giving us p is equal to n minus k minus m. In summary, keep this in mind. All of the rules that we know will stay the same. All of those properties of algebra are still in play. It looks a little different, but the process of solving it is very similar to what is currently being done. As always, feel free to email me